Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and this week I'm going to discuss water coil circuiting. So last week I mentioned that the number of circuits was basically how many connections there are to the header on a water coil. So this is a drawing from last week, and if you remember I had a 3-circuit water coil. And as I look at this now, I realize that I show the water entering from the top and exiting out the bottom, but actually you want your water to enter through the bottom. So this up here is an exit, and these over here are where the water enters, because you want any air bubbles to float to the top. Okay, now that our drawing's correct. So water would enter here, here, and here, and there would be a header that connected all of those. And water would exit over here, here, and here, and there's a header that connects all of those. And so the piping comes into the header and supplies all 3 circuits at the same time. So let me draw a side view of this water coil. So we'll just show the circuits going back and forth in the water coil. And I'll draw the second circuit in a slightly different color just so you can see the difference between all 3 circuits. And then we'll draw the third circuit. So we'd have water entering the water coil at the bottom of each circuit, here, here, and here. But wouldn't it be easier if we connected our 3 circuits into one big circuit? So we connect here and here. And now let's get rid of our arrows from our 3 entry points. And we would just have water coming in here at the bottom, and it would exit the coil at the top. So this may be possible, but there's a couple things that circuiting in a water coil does. First, you want to get the inlet and the outlet of the water coil on the correct side. Usually this means on the same side, so all your piping connections come to the same area. Second, you want to control the velocity of the water through the water coil. The water velocity affects the pressure drop and performance of the coil. Running one long tube like this would increase your pressure drop across the coil, which will affect the size of your pumps and can increase costs. So those are related to pressure drop. Let me make a little bit of room here so I can talk about performance. So the velocity of the water is important for performance because if the water moves too slow, you could have laminar flow. This is where all the water is traveling smoothly through the coil and there's no turbulence in the tube. With laminar flow, some of the water is traveling in the center of the tube and never touches the tubes to transfer heat, so it reduces your performance. Turbulence is needed for heat transfer. Basically, the water splashing around the insides of the tube and making contact with the tube is what is transferring the heat from the water, in the case of a heating coil, to the tubes. So laminar flow can happen at velocities below 1 foot per second through the water coil. You can also have too high a velocity through a water coil. Above 6 feet per second velocity, the water may be traveling too fast and your heat transfer also drops, because the water is just moving too fast to transfer all of its heat to the tubes. This also significantly increases the pressure drop across the coil. So ideally, you'd have between 1 foot per second and 6 feet per second velocity through your water coils. So that's the importance of water coil circuiting. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.